following is my video of my attempt and my process to solve this Packet Tracer Lab 12.3.1, where you use ICMP, namely ping and trace, or traceroute, to solve connectivity issues in a LAN with a number of hosts, some routers, and a remote server that they all need to access, as well as accessing each other. Now, I'm the furthest thing from an expert in Cisco networking. This is a case of the blind leading the blind, if you might come here for help. And actually, part of what I hope to gain from making this video is that if and when you see me make mistakes or chase my tail in this video, which I've already cut down to reduce some of the monotony, point it out in the comments so I can learn from it. Bam! Let's have a look at this problem description. Customers have been complaining that they can't reach some network resources, and we have been asked to test connectivity in the network. We're going to use ICMP to find out which resources are unreachable and the locations from which they can't be reached. Then, we will use trace to locate the point at which network connectivity has broken. Finally, we will fix the errors that we find to restore connectivity to the network. Our instructions are given as follows. All hosts should have connectivity to all other hosts and the corporate server, end to end. We can see here that the corporate server appears to be on a separate remote network. All the other hosts are on our local network that we have to worry about. And there's a number of hosts here. There's certainly more than some of the other Packet Tracer labs that you'll get started with on Netacad. In any case, the other instructions. We should wait until all link lights are green before we start, which is now the case. We should select a host and use ping to determine which hosts are reachable from that host. If a host is found to be unreachable, we will use ICMP trace to locate the general location of network errors. Then we will locate specific errors and correct them as best we can. We've got a full table of addressing information, but it's very helpful to write down the information that you're gathering and keep a table of information about devices in the network. So I'm going to start with putting what we're given into my spreadsheet. So here in our spreadsheet, I'll put what we know. Last night I was copying over the information into a spreadsheet so that it wasn't just a pasted picture, but I think that's a waste of effort. In any case, our first task is to ping devices and see what's reachable from each device. So what I'll do is create a table with a from side and a to side, and we'll mark if such and such device is reachable from such and such device by ping. Alright, now let's go from PC1 to a bunch of other devices to start with. PC1, open command prompt, and we're going to see if PC1 can reach laptop A, then PC2, 3, 4, server 1, laptop B, laptop C, corporate server, so on like that. It's helpful that we've got the table here too. Let's try it out. Start by pinging laptop A, 10.10.1.20. We get an immediate reply. That's a check. Let's ping PC2. Now right away we notice that it's an IPv6 address for PC2. We get nothing. That's our first two. We can reach laptop A, but we can't reach PC2. Oh, the switch doesn't perform routing. Duh. So the error we were trying to locate. Switch 3 cannot connect to the corporate network. R3 can. Oh, it occurred to me I should be using trace. So switch 3 cannot access the corporate server. Let's see where the attempt breaks down. Show the trace. Trace. So when we try to trace the route from switch 3 to the corporate server, it gets nowhere. I think that actually confirms that it's not getting to router 3 as well. I was trying to think of a way to test that. I wasn't coming up with it. No, it's not hard. Let's try the same thing. 2030. Now in any case, we have to type Control-Shift-6 to abort. PC1 is able to reach the corporate server. Let's try doing it with the IPv4 address. What am I misunderstanding here? 203.0.113.100. All right, we get more sensible results when we do it from the routers. Trace 203.0.113.100. Both routers are able to reach the corporate network, which we knew. The hosts in the first two subnets are able to reach it too, so there must not be a problem with the switches. I'm just missing some understanding. From either router, you can reach the corporate server. So naturally from the main router, you'll be able to as well. I'll do it anyways. Yeah, and it just makes the two hops from the router out to the corporate server. If we go to this host, let's try tracing the route. It should be trace route, like trace RT. 2001, DB8, cat. Tracing the route to the corporate server. think we can. Let's see if this device can reach its own default gateway. FE80. Yes, it can. Trace route to this. So when we're on laptop C and we try to ping the corporate server, it goes nowhere, but we already knew that. Let's see what happens when we try to trace the route. Seems we don't go anywhere. So I'm really wondering about the default gateway on this laptop C. The default gateway is set as FE80:1. It should belong to this router 3. FE80:1. That seems to be correct. FE80. We can't reach the default gateway. From the default gateway, we can reach the corporate server. Let's trace. Let's check the default gateways of the routers. That doesn't make any sense now. It's just different interfaces. So from PC1, we can reach the corporate network, as from PC2. From PC3, from PC4, we can reach the corporate network. From R3, we can reach the corporate network. From switch 3 and switch 4. From switch 3 and switch 4, from the hosts below them, we cannot. So there's some connection break in there. Switch 3 should have router. After some lunch, I came back to this and noticed an issue. Server 1 has no IP configuration. We've got to give it the IP subnet mask default gateway that it's supposed to have. So server 1 is supposed to have the IP address 10.10.5.20. Subnet mask equivalent to 24 network bits. And the default gateway 10.10.5.1. You'll notice the little completion meter says that that problem actually gave us the majority of the completion points. In any case, I found that out just by panning through the IP configuration on each device, and it explains why, let me flip back, server 1 and PC4. Server 1 could not reach PC4, and PC4 could not reach server 1, even though they're on the same subnet and anything. As a matter of fact, server 1 couldn't reach anything. That was because it didn't even have an IP address. Now that's fixed. Let's look at the configuration for PC4. It's completely correctly configured. It remains to find the rest of the issues. And now we can reach the corporate server from server 1. Reach the corporate server from server 1. But what about PC4? PC4 still can't. So if server 1 can reach the corporate server, and PC4 can't, then I would think that isolates the problem to PC4. Because when server 1 tries to go out to the corporate server, it's passing through the switch, the router, this other router, and into the wider network without issue. So I think I'll look at other parts of the configuration of PC4. Now, PC4 is supposed to have the address 10.10.5.10. It's supposed to have the... Wait a second. PC4 is supposed to have the IP address 10.10.5.10, the default gateway equivalent to 24 network bits, and the subnet mask equivalent to 24 network bits, and the default gateway has been set incorrectly. You can see here in the table, PC4 is supposed to have a default gateway of 10.10.5.1. It's actually got 11 here. That's another problem out of the way. Let's try pinging the corporate server now. And we're live. So PC4 can now reach the corporate server. Let's look at some other configurations. Laptop B. Laptop B, DB8, 5, 10, 64 prefix. That's completely correct. Configuration for this one. 5, 20. That's correct. So is the default gateway. Now we've got the problem 71% solved. It just remains to find that last little bit. My understanding, laptop B and C should still not be able to reach the corporate server. Let's try the IPv6 address. Laptop C still can't. Neither can laptop B. I'm going to look at their config again. Default gateway, laptop B. It's all as it should be. Okay. So switch 4 still cannot ping the corporate server. Why can switch 4 not ping the corporate server? But as I recall, router 3 can. 203.0. Router 3 can. So we've isolated the problem. Switch 4 cannot reach the corporate server, but RTR3 can, router 3 can. what is going wrong between these two hosts on the network, between the switch and the router? Let's see what's in the routing table. Maybe the interface of the router that connects to that switch has something wrong with it. Alright, so laptop C has the default gateway. No, we've got to use IPv6. Let's take a look at how router 3 is configured and see what its addresses are set to. Show IPv6 in brief. Well, that's what I had just typed anyway. So, router 3, gigabit Ethernet 001, should have the address 2001 DB851, but it's actually 61. Let's fix that. We just need to change its address to what it's supposed to be. See. And with that, I guess we're done. Let's ping the corporate server from laptop B. We should be able to reach it now with those issues ironed out. And we're on the IPv6 network. Nice. We can ping IPv6 hosts on other subnets. Not the IPv4 hosts on other subnets. From laptop C, we could probably ping PC3. 2001 DBA 1. Yes, we can. So, now I notice something about these instructions. All hosts should have connectivity to all the other hosts. Now, we can get from laptop B to another IPv6 host, but not to an IPv4 host. So there's a bit of a caveat on what they mean by all hosts should have connectivity to all other hosts. Because it appears that it's actually acceptable that the hosts running the different versions of the internet protocol actually can't directly communicate. Maybe this isn't meant to show some kind of bridging of the two protocols.